Good morning everyone. In this video lecture series, I am going to explain about minimum shift keying, that is nothing but MSK. MSK is one of the most spectrally efficient modulation schemes which is available in the digital communication. Due to its constant envelope, it is resilient to nonlinear distortion and there were chosen as the modulation technique for the GSM cell phone standard. MSK is a special case of continuous phase frequency shift keying, which is a special case of a general class of modulation schemes known as continuous phase modulation. It is worth noting that CPM is a nonlinear modulation and hence by extension MSK is a nonlinear modulation as well. Nevertheless, it can also be cast as a linear modulation scheme, namely offset quadrature phase shift keying, which is a special type of phase shift keying. Here, MSK will be considered as a continuous phase shift keying, which is defined for the interval 0 is less than or equal to t less than or equal to tb as follows, where s of t which is equal to root of 2 eb by tb cos 2 pi f1 t plus theta of 0 for symbol 1. And we'll be using the same for the symbol 0 also, where eb is nothing but the energy bit which is in the transmitted part. tb is the bit duration. The phase theta of 0 denoting the value of the phase at time t equal to 0 sums up the positive history of the modulation process up to the time t equal to 0. Then the another useful way of representing the CPSK signals is to express it in the conventional form of an angle modulated signal as follows. When the phase theta of t is a continuous function of time, we find that the modulated signal S of t itself is also continuous at all times, including the interbit switching times. Then the phase theta of t of a CPFSK signal increases or decreases linearly with time during each bit duration of a TB seconds, where theta of t which is equal to theta of 0 plus or minus pi h by TB into t. The plus sign corresponds to sending symbol 1, that is 0. We find that where Fc plus h by 2 Tv which is equal to F1, whereas if you use minus sign will be call it as a F2. Thus we get Fc which is equal to 1 by 2 of F1 plus F2, where h which is equal to Tb of F1 plus F2, where h is referred to as the deviation ratio. With h minus 1 by 2, the frequency deviation equals half the bit rate. This is the minimum frequency spacing that allows the two FSK signals representing symbols 1 and 0 to be coherently orthogonal. At time t which is equal to tb, theta of tb minus theta of 0 which is equal to pi h for symbol 1 minus pi h for symbol 0. The sending of symbol 1 increases the phase of the CPSK signals S of t by pi h radians, whereas sending of signal 0 reduces it by an equal amount. Where MSK is a form of continuous phase frequency shifting, providing spectrum efficiency and enabling efficient RF power amplifier operation. Then it has a future that there are no phase discontinuities and this significantly reduces the bandwidth needed over other forms of phase and frequency shift keying. This is nothing but the transmitter of a MSK, where the signal input signal cos of 2 pi FCD is being given along with the mixture of cos of 2 pi T by 4 into TB. Then it is being given to the band pass filter FC plus FB by 4. Then the band pass filter FC minus FB by 4 is being given, and it is giving finally given to the summing process, and where MSK signal S of t is being carried out. The next one is the MSK receiver, where the input signal is being given to the summing amplifier, that is will be having here the in-phase channel and the quadrature channel. From the in-phase channel will be integrating that and being given to the decision device, where the threshold value will be here 0. Then from the quadrature channel it is being given to 0 of integrated to 0 of TB, and it is given to the decision device, where it has the threshold value of 0, and finally it is given to the phase estimate, and these being combined and given to the logic circuit for interleaving the phase decisions, and finally the output binary sequence. This is nothing but the power spectra of a MSK signal. The main advantages of this is it has a smoother waveforms, it has continuous phase in all the cases. There is no amplitude variations. Main lobe is wider and it contains 99% of the signal energy. It has less interchannel interference. It has good BER performance, self-synchronizing capability, MSK spectrally efficient modulation scheme, and is particularly attractive for use in mobile radio communication systems. The main disadvantages of it is the generation and detection of MSK signal is slightly complex. Here the bandwidth of MSK is 1.5 FB, where FB is in the QPSK. The main assessment is what is meant by MSK and the modulation index, the probability of possible error. Thank you.